With the objective of producing modular structural systems, Fisac dedicated his career to perfecting tectonic prototypes. The Pato Hueco and Bumeran both explore the potentials of concrete and the structural capacity of hollow beams and columns. The beams use minimum material for high efficiency. The manipulation of the original shapes allow for the beams to be both structural and carry specific functions, such as collecting water and insulation, for example. Because Fisac produced simple extrusions, we are interested in challenging this strategy by creating a system that allows for differentiation. For the first assignment, we milled and casted Pato Hueco and Bumeran. We also 3D printed a loft between the two cross sections in order to explore a methodology for producing a differentiated beam. By reproducing the Pato Hueco and Bumeran, we were able to discover that the forms Fisac designed are all based on the manipulation of an equilateral triangle. At this point, we are interested in refabricating Fisac by generating a system that allows for the flexible manipulation of the triangle, with the intent of 1. Creating a differentiated beam, and 2. Assigning differentiated functions to the surface generated. Our intent is to create a system for generated differentiated beams, which can produce differentiated roof conditions along a surface. These roof conditions are guided by a set of functions such as water collection, soil for planting, and light. While each form responds to a specific function, they are also able to affect each other to create differentiated fields. After compiling information on Fisac's modular systems, we made an attempt at abstracting the original cross-sections to a combination of points that move in particular relationship to each other. The system allows us to explore endless combinations of point relationships. Though highly abstract, these give us a sense of what the limits of the system are when translated to physical objects. If the intent is to generate differentiate function-loaded beams, we can pick and choose which sections may work best. In order to find differentiation, we first divided functions into 3 categories: 1. Soil, 2. Water, and 3. Light. Within each category, we explore the cross-section's limits in order to better understand the potential variability. Soon after, we combine the different functions into a set of rules that can generate differentiated sections. There is a parallel relationship between the beam and the field it produces. Arraying a set of differentiated beams along a given set of guidelines produces varying field conditions. These fields are guided by a set of rules that in turn produce very recognizable patterns. We first establish a set of relationships between cross-sections along a beam. This order carries the organizational rules governing the field. The fields therefore have inherent qualities embedded in its organization. Each field produces a different roof system, each with particular effects. They can be expanded or contracted to create larger or smaller grains.
take a long, long time. I've got to figure out love. It's such a tricky thing. Can include diamond rings. Will make you scream and shout. If there is no way out, I've got to figure out love. I've got to figure out love.
After exploring the large-scale organizational characteristics, we shifted into the small-grain, tectonic detail of the beam. By zooming into the surface of the beam, we're able to apply different textures and patterns. These are meant to add another layer of formal and functional understanding. By exploring different methodologies for channeling water, piling soil, and allowing light in, we can better generate specific qualities and tactile experiences. We constructed our 4-feet beam that exemplifies the different functions and qualities of the system we propose. The fabricated sample is meant to show the formal and programmatic changes that happen along the beam. In order to maintain structural and tectonic integrity, we decided to cast. The molds were designed in Rhino and translated to Mastercam for 5-axis milling.